We are doing exercise 10C, and in this video we are looking at question 16, which says that Joan is offered a selection of 5 different sweets. She can choose to pass or to select any number of them. In total, how many choices does she have? So let's really analyze what this question is asking of us, and let's see if we can figure out what my n value is going to be and what my r value is going to be. So n is simply the number of objects that I'm choosing from, and right here we are offered a selection of 5 different sweets. So she has 5 options before her. Now, she can choose to pass or to select any number of them. In total, how many choices does she have? Do you notice that something is absent from this question? Hopefully you do, and that is the fact that we are not told that she has to select a certain number of sweets. It doesn't say she has to choose 2 sweets or she has to choose 3 sweets. Rather, it says she can choose to pass or to select any number. Let me highlight this in green. Any number of them. So R is not specified. And there's a special rule that we need to follow when R is not specified. And that is this rule right here. So selections of any size. The following result is useful when asked to count all the combinations of any size from a group of n objects. So let me repeat that right here. When we are not told what our R is, we need to use this right here, this formula right here. And let me break down for you what this means. So let's begin with our first one right here, NCO. So we're going to have n, our combination, then 0. Now what is our n? We know our n, let me highlight that in yellow, because it's very important. We know that n equals 5, so I can come down here and get rid of that and put 5 in its spot. So what this is saying is that I have 5 options. How many different combinations are there if I select 0? Now obviously my answer is, now this might actually throw some people, my answer is 1. And what that means is that there's one way to select 0 things. There's just that one way of doing it. There's not multiple ways of collecting 0 things. If there are 5 things in front of you and you don't take any of them, there's only one way to do that, not to take any of them. There aren't any other options. So that's why our first one is going to be 1. Next, we have NC1. Well, we know that my n is 5, C1. So this says I have 5 sweets in front of me and I'm going to select one of them. How many different ways are there for me to do that? Well, obviously there are 5 ways for you to do that. You could pick just one of them, and if there's 5 different ones, there are 5 ways for you to do that. If you really want me to prove this too, you could do it yourself by going onto your CAS, going on to combinations and typing in 5 and 1. And what you're going to find is whenever your group size is 1, your answer is simply just going to be what the objects is, the amount of objects there are going to be. So in this case, 5. Let's keep on going. The next one we have is NC2. So I have 5C2. So what this is saying is that I have 5 sweets in front of me. How many combinations are there if I only select 2 sweets? Well, I could use my calculator to solve this. The answer will be 10. So what I'm doing, and remember I'm plussing these, so there are 10 combinations of choosing 5 different sweets if I only have groups of 2. Next, I'm going to go 5C3, and there's actually going to be 10 of those as well, I believe. So if we do that, there's going to be, so now I'm getting groups of 3. Again, there is 10 ways of doing that. Then I have 5C4, and I know that whenever my group size is 1 less than my object size, it's simply going to be this, the amount of my objects, so 5. But again, I can prove that to you by going like this. 4, it's going to be 5. I already wrote that down. And then my last one is just 5C5. Now, how many different combinations are there if I have 5 sweets in front of me of collecting 5 sweets? Now, hopefully you can see that it's just going to be 1. If you have 5 different sweets in front of you and you take all of them, there's only one way to take all of them. Remember that the order isn't important here, so there's only one way to do it. So this is really a neat thing to remember, that there's only one way to take everything, and there's only one way to take nothing. And let me again just prove that to you by coming over here and putting in 5. So you can start to remember some pretty important principles, such as whenever my my objects and the size of my group are the same number, my amount of combinations will be 1. Whenever my group size is 1, the amount of combinations I'm going to have are 5. And whenever my group size is 1 less than my objects, my answer is just going to be the objects. So that's all pretty much a mouthful, but hopefully you can understand how we got each of these. So now what this is telling me is I simply need to add these together. So 5 plus 5 is 10, 20, 30, and then 1 plus 1 is 32. So my answer is going to be 32. Now that took quite a bit of time, and as you can see here, there is a shortcut we can use. All of this is going to equal 2n. So all of this is going to equal 2n. And we know that n is just my objects, so 5. So what is 2 to the power of 5? Well, we know that 2 to the power of 5 is 32. And just like that, we have answered this question. So we could have answered this question far quicker. We could have simply gone, well, I have 5 different suites. They have not specified the size of the group. So it's simply going to be 2 raised to the power of n. So 2 to the power of 5 is 32. But I took some time and walked you through this slowly. So hopefully you understand what's going on now when asked a question where the selection can be of any size. Hopefully this has been helpful to you.